In this video, we're going to do particle movement with net distance and position. In our first example, find the net distance traveled from t is 0 to t is 4 if v of t is 2t minus 6. Then we want to find the particle's position at time 4 if s of 0 is 3. So first of all, let's deal with net distance. Net distance is simply integrating over the time interval, in this case 0 to 4, of velocity dt. Don't forget to put your dt. If you integrate, we would get t squared minus 6t from 0 to 4. Plugging in, we would get 16 minus 24 minus 0, which would give us negative 6. So our net distance is negative 6, which means that from wherever the particle started, the particle is now 6 units to the left of that position. Well, in the second part of the problem, the initial position was 3. The particle has traveled negative 6, which would give us a position of negative 3. In this example, this time instead of given a function, we are given a graph. Given the graph, find the position of the particle at time 6 if s of 0 is 1. So we know that our initial position is 1. We want to add to that the distance traveled from 0 to 6 for the velocity function dt. Well, in the picture, the areas are represented in red, and so we can tell that when we integrate, we have a negative area of 2, we have a positive area of 6, we have a negative area of 4, and a positive area of 2. And we're going to add to that the initial position of 1. Well, so obviously the negative 2 and the positive 2 cross out. 6 minus 4 is 2, so we get 1 plus 2. So the position of the particle is 3.